Welcome, fine physics folk. This is going to be the last assignment before spring break, and all I want to do is take some time and go through some of the concepts that were in the presentation that was posted on Monday. If you have not had a chance to go ahead and look at that, please do. Today's assignment is going to be another Google Forms, multiple choice questions, and I got some feedback that I need to do some more example problems, so we're going to do some more of that today. We're going to review some of the concepts, and hopefully the way I explain it now will answer some of the questions that you have. And again, please, please, please do not hesitate to email me if you are confused. So on Monday, the PowerPoint that we went through, the little video we went through, talked about these two words, work and power. Work, there it is, work and power. And work and power are very important in physics. Work is defined as a force over a distance. So if you push something and it moves, if you push something and it moves, you do work. You need to push it and it needs to move. If there is no movement, there is no work. So pushing a force over a distance. So if you go to a wall, and I said this yesterday, or you go to the side of a building or the floor, great question. If you do push-ups, you are on the floor and you are pushing against the floor. Are you doing any work to the floor? No, the floor doesn't move when you do a push-up. However, are you doing any work? Well, yes, your body is moving. So because your body is moving, you're doing work on your body, but you're not doing work to the floor. Okay? Power is how fast that work is done. So, okay, you can do a push-up. You can do it quickly or you can do it slowly. If whether or not you do it quickly or slowly, you're going to do the same work. However, the difference is the power required to do it. Power is how fast work is done. Power is how fast work is done. So if you do something quickly, it takes more power, even though you're going the same distance, you'll do the same work. So let's think about it. If I lift a box into actually, you know what I think about it as lifting weights. So you're doing reps, you're doing arm curls, right? So let's picture you're doing arm curls. You are lifting the weight a distance. Whether or not you do it quickly or slowly, you do the same work. However, if you lift that weight very, very fast, even though you're doing the same work, you're using more power. So sometimes when you go to the gym, you're doing weights, you want to get into a rhythm. You don't want something called momentum to kind of keep pushing your reps forward. And if you don't lift weights, you don't know what that is, don't worry about it. But all I'm trying to say is you don't want to sit there and do 10 minutes on lifting a weight 10 times. That's not going to be very useful for your muscles because you're not using enough power. You're doing the same work, but you're not doing enough power. So if you're lifting a weight, and if you lift this weight the same distance, it doesn't matter how fast you do the same work. So if I do one rep, that's a certain amount of work. It doesn't matter how fast I do it. If I lift it the same distance, if I do one rep, I'm doing the same work. However, if I lift it faster, if I do that rep quicker, I use more power. One rep is one rep. One rep is going to be the same amount of work. So after I do that, the only thing that's going to change is the power. If I do it faster, I have more power, even though the work is the same. So here's the take-home message. If you push something a distance, you do work. Work has nothing to do with time. So if you lift it a certain distance, you do a certain amount of work. Let's think about it. Okay, how about this? I think we should put some numbers here. Let's just say I lift a 10 Newton weight, 1 meter. Work equals force times distance. So 10 newtons, 1 meter, 10 times 1 is 10 joules. All right, so if I lift this 10 Newton weight, if I lift it 1 meter, I do 10 joules. Nowhere in that equation is time. Time doesn't come around until we get to the other equation, work equals power times time. Or we could write it like this, the WPT. This is a very important concept, and I do ask a couple questions about it, and that's why I'm really going over this now. So if we did 10 joules of work, okay, if I did that in 1 second, 10 divided by 1, my power is 10 watts. However, if I lifted that same weight in 2 seconds, if I double the time, this is an inversely proportional relationship. We started to talk about this a little bit yesterday, but power and time are inversely proportional. If I increase the time from 1 to 2, what's going to happen to the power? If I increase the time, the power is going to decrease. 10 divided by 2 is 5. So I've done the same work. The work hasn't changed. But the difference is, as the time changes, the power changes. With more time is less power. Or with less time, there's more power. Inversely proportional relationship. Okay, and I cannot stress this enough. We need to keep the units straight. And I said this before, and I want to say it again. These are the triangles. So when I see these are the W, F, D, and these are also the W, P, T. All right, so the quantity are these triangles. So all these 5 things here go into the triangles. When I see these 5 things on the right, these are the units. These are the labels after a number, and these appear after a number. After number. Okay, cool. Really important that we know that. A lot of people were confusing that on Monday's assignment. So, what is the new thing that I want you to do? Now this is going to be the same math, the same 2 equations, but now it's called the double triangle. One question is going to use both triangles. So what I'm going to do is I'm going to spend the rest of this presentation doing sample questions on how this is going to work. If you feel like you understand how this works, that's great. I'm going to do 4 sample questions that explains how to solve a problem like this, because this is absolutely on the assignment for today. So we have the 2 triangles, the WFD and the WPT. It says how long. Stop. What are you looking for? How long? How long means time. So time equals question mark. Will it take to push an 18 Newton chair? 18 newtons. 18 newtons. Oh, 18 newtons is a force. So the force is 18 newtons. Good. 4 meters. 4 meters. Meters is a distance. It goes back to that chart. If you guys don't take notes of these presentations, it might be a good idea to take out your notebooks and jot a few of these notes down. If you use 10W, okay. Now when I see 10W in a question, because it's a unit after a number, I know that that has to be watt or power. It's not 10 work. That's not how it would appear in the equation. So whenever I see W after a number, that is the power. Okay, so I have my 2 triangles. I have my variables. I'm looking for the time, but I only have the power. I don't have the work and I don't have the time on this triangle. So this is what I'm going to do. Take a look at this. Okay, I'm going to fill it in. I'm just going to fill in what I know. I'm going to redraw the triangles. I'm going to fill in what I know. The force is 18, so where it says F, I'm going to put 18. The distance is 4, so where it says D, I'm going to put 4. The P, I'm going to put 10. And the T is what I'm going to solve for. Now here is the key. Here is the link. I don't know the work. The work is not in either triangle. But if I look at the triangle to the left, I could solve for the work. 18 times 4. 18 times 4 is 72. So I know that I've done 72 joules of work. And if I know one of the works, I know the other work, 72. They are the same. The W's are the same. So if you could get one W, you actually have the other W. 18 times 4 is 72. 72 here, 72 here. Oh, now I got my two numbers. Now I could solve for the time. 72 divided by 10. Oh, the time is 7.2 seconds. The unit for time is seconds. That's it. That's it. So now what it is we're going to use the same two equations we already have, but now we're going to use both equations in one question. It's called the double triangle. All right? Let's see another one. Ah, look at this one. How far? How far is distance? D equals question mark. Let's see how this one's going to play out. 30N dumbbell, well, 30 Newton dumbbell. So when I read it, this is the strategy I want you to do. 30 newtons is the force to go. If it is lifted with 20 W, 20 W is the power. When I see W written in a question, it's the power for 3 seconds. 3 seconds. 3 seconds is, of course, time. All right. Let's see how this one's going to go. We got the W, F, D triangle. And we got the W, P, T triangle. Awesome. All right, plugging in. I'm going to redraw the two triangles, and now underneath, I'm just going to plug in the variables. All right, so F is 30. Awesome. D, I don't know, distance, we don't know. That's what we're looking for. Okay. P is 20. And then T is 3. Ah, I got it. Take a look at this. On the triangle to the right, I have the power and the time. I multiply those and get the work. The work is 60. If this work is 60, that means this work is 60. 60 divided by 30, well, that's easy. The distance is going to be 2. Okay, nice. What about this one? How much power? Stop. What are we looking for? We're looking for power. So P equals question mark is used to move a 12 Newton cat. 12 Newton is the force. 4 meters. 4 meters is a distance. 4 meters is a distance in 20 seconds. 20 seconds, 20 seconds is a time. Nice. Okay. Now, let's go ahead and try to figure this one out. I'm going to draw the two triangles. W, F, D, W, P, T. You know what might be a good strategy? If you want to see if you could solve this on your own without me going through it, why don't you pause the video here, solve it out, and then see if you get it right. Okay, what I'm going to do now, though, is plug it in and see if I can get. All right, so where it says force, I'm going to put 12. Where it says distance, I'm going to put 4. Where it says power, we don't know. That's going to be our variable. And where it says time, I'm going to put 20. Okay. So how's this going to work? Sorry. Drop things. I'm very clumsy. Still very clumsy, even though I'm at home. All right. To get the work, I'm going to do 12 times 4. I'm going to look at the left triangle. So to get the work, it's going to be 48. If this is 48, that means this is 48. And 48 divided by 20 is going to give you your answer of power being 2.4 W, 2.4 watts. And I want you to know, I love decimals. The last one we're going to do together is this one. So essentially we did 4 problems, and as you see, there's 4 variables that we solved for in the triangles. This is going to be the last variable. It says how much force? Force equals question mark. Yes. Is need to push a branch 5 meters. Distance equals 5 meters. If 100 watts, okay, 100 watts. When I see W in a problem, 100 watts is the power over 10 seconds. Okay, 10 seconds, and 10 seconds is, of course, the time. So, 2 triangles, W, F, D, and W, P, T. Awesome. Let's plug it in. Let's see what we get. All right, we're looking for the force. We know that the distance is 5. Okay, so far so good. The next triangle, I know the power is 100. I know the time is 10. Ah, okay, take a look. To get the work, I'm going to do power times time, and 10 times 100 is 1,000. If that's 1,000, then this is 1,000. So the force is going to be 1,000 divided by 5, or the force is going to be 200 newtons. All right. So again, the process is the same thing. You make your list of variables here, make your list of variables, write out the triangles, plug in, and solve. The key is that once you have one of these W's, you have the other W. These W's are the same. That's the key to all these problems. So your homework tonight, your assignment for today rather, is another 10 questions on the forms. I really would like to see you take a little bit of time and actually maybe do out some of the work on a scrap sheet of paper, have your notes sheet, or watch this video, open a separate tab where you're like, okay, what's this? Just turn to the video to get the information that you need. I think a lot of people just selected random answers to the questions, and I want you have the information to do this, and if you really don't know what you're doing, I am here. Take some time, really put forth your effort, and if you were just totally lost, please reach out to me. I think you got this, and once this is done, this is the last major assignment before spring break, and we all need this well-deserved break. I will see you guys sometime. Be well.